Kurtz here, and this is Easy Access Math. And today we have a review lesson on hypotenuse. That's where you see our right triangles. And let's fix this one and give it its right angle, because that helps you see where the hypotenuse is. When you find the right angle with the two straight sides, you just draw a line and that will point to the hypotenuse. So, as you can see in the first one, I'm missing the hypotenuse. That's what I'm solving for. So I do the standard formula, a squared plus b squared equals c squared. That's the Pythagorean theorem, where a and b are your straight sides and c is the hypotenuse. It's always the largest side. So if I follow that, I have 9 squared plus 6 squared equals c squared, which gives me 81 plus 36, and I add that up. 81 plus 36 is 117. 117. And my final step is I square root that answer. And as the case may be, there's no perfect square that goes into 117, so I can't simplify it. I just leave that as the square root of 117. Now in my second hypotenuse, it's a little different. I'm missing one of the sides. So I like to turn the formula backwards. C squared minus b squared equals a squared. A and b are interchangeable. They could be either of the straight sides. Remember that the legs are interchangeable, so a and b could be either of them. And I have c squared, which is 9 squared, minus 6 squared, equals a squared, the missing leg, the missing side. And that would give me 81 minus 36 equals, and so we subtract 81 minus 36, and that gives us a total of 45. And 45, believe it or not, can be simplified. When I square root it, it could be 9 times 5. And if you remember our video on simplifying radicals, the 9 comes out as 3. And the radical 5 stays in, giving me an answer of 3 radical 5. The 9 comes out as its root, which is 3. So the missing side would be 3 radical 5. This one would just be the square root of 117, because that number cannot be simplified. Check out our other videos on hypotenuse and other math topics at Easy Access Math.